Hello class, welcome to this video on the Spring Break Challenge Part 5. So we're going to go over the next 5 questions. So let's go ahead and get started. A quadrilateral PQRS has vertices given below. So we got PQRS. Which type of quadrilateral is this? Okay. All right, before we dive into it, let's just review a couple of things. So we know that, so let's look at the rectangle, rhombus, and square first. So we know that for something to be a parallelogram. So let's just start with parallelogram and review those features. For something to be a parallelogram, we know that the opposite sides have to be congruent. We know that the opposite sides have to be parallel by definition, and we know that the opposite angles are congruent, things like that. But we also know that the diagonals are not the same length, but they do cut each other in half. Okay, so in order to prove a parallelogram, you have to show that the sides are parallel, or you have to show that we have opposite sides are congruent. You have to show that the diagonals cut each other in half or bisect each other. All right, and in order to do that, you have to find out lengths, distances, slope, things like that. All right, now now for rectangle, for a rectangle, you'd have to prove that this rectangle is a parallelogram. So you'd have to prove, the same properties that a parallelogram has. But then you can also show that the diagonals are congruent. So they're all the same length here. And obviously, you can show the right angles. And how do we prove right angles? We prove it with slope, right? And things like that. And then with the square, or with the rhombus, remember that a rhombus is a parallelogram where the sides are congruent. So these sides are congruent. That's a rhombus. And on a rhombus, the diagonals are perpendicular. So if you prove that the diagonals are perpendicular for a four-sided shape, then that shows that it's a rhombus. And obviously it has to be a parallelogram. And then, so then if you want to prove a square, then you have to prove both of these things. Okay, so to prove a square, you have to prove, the diagonals are perpendicular. They're the same length. The angles are right angles because it's, part of a rectangle and all of that. Okay, so just wanted to show you the properties of these. And then you have the kite, which is the last one. So the kite has the property where, these two sides are the same, these two sides are the same. So the diagonals are perpendicular, and this is cut in half here. And these angles are congruent, right? The opposite angles there. There's a lot of properties that you need to remember. Okay, so let's look at this one. So let's see if we can prove which one it is. So I'm just going to draw it out real quick. So we got -2, 3. We got 1, 3. And we got R is 1, -2. And then this is -2, -2. And so by drawing it, you can get a better picture of what's going on. You can see that this is a vertical line and this is a horizontal line, and therefore it must be a right angle, okay? So you can show that, or you can see that here. So we do have right angles here. So, and so then in this case, it would be a rectangle, right? But normally you would show that these are right angles by doing the slope, right? So to show that two things are perpendicular, you need to look at the slopes. The slopes are opposite reciprocals. So if one of the slopes is 1/2, or like 2/3, then the other slope is -2/3, okay? So these are things you have to remember, not necessarily for this particular question, but just in general, okay? All right, so let's look at, we would also have to show that these are parallel, but we already know that they're parallel. It's pretty obvious from the picture. All right, so let's look at number 22. A quadrilateral has vertices given. Select all the statements which are true. Okay, so it's another quadrilateral example. So we get 0, 0 for P, And make sure you draw the graph and then the notes that follow for your notes. Okay, so we got -1, 3, we got 5, got R here, and then we got S is 6, -2. Or no, S is 6, 2. Sorry about that. S is 6, 2. Let me double check that. So 0, 0, then I got -1, 3 for Q. And then I got 5, 5 for R, and then 6, 2 for S. Okay. All right, so we got that shape. So now it says that the slope of opposite sides are both -3. Let's see if that's true, okay? The slope of the opposite sides, PQ and RS. Okay, so PQ and RS. Let's do the slope. So again, remember to do the slope, rise over run. So from Q to P, you got to go down 3 and over 1. All right, so 1, 2, 3. And then here you got to go from R to S. Remember, R is at 5, 5, and S is at 6, 2. So you got to go down, you got to go over 1 and down 3. All right, so we know that the slope of QP is rise over run, so it's going to be -3 over 1. The slope of RS is going to be -3 over 1, rise over run, or rise over run. Okay, and so that means that these are parallel, okay? Now, they don't look parallel in this picture, then that's just because it's the scale that I've drawn this in, which explains why they don't appear parallel. But we can show that they're parallel according to the calculation. All right, so we got the slope of those opposite sides must be parallel, and they're both -3. All right, and so let's check QR and PS. QR and PS. Okay, so QR looks like it goes up 1. It goes up 2 and over 1, 2, 3, 4, 5, 6. Okay, and this here it goes over 6 and then up 2. So then the slope of QR is rise over run, so 6 over 2, which is equal to 3. Or rise over run is, sorry, it's 2 over 6, sorry. Rise is 2 and then run is 6, which is 1/3. And then the slope of RS, or not RS, PS, is up 2 over 6. So it's the same thing. So then that means that these are parallel, right? And they're equal to 1/3. So therefore, they're parallel, so that's good. So that means we have a parallelogram because opposite sides are parallel. And then it says the slope of the opposite sides, PQ and RS, are both 3. No, so we just said that it was -3, right? So it can't be that. Okay. So let's get rid of that. And then slope of opposite sides QR and PS are both -1/3. No. The product of the slopes of each pair of adjacent sides is 1. Hence, the adjacent sides are perpendicular. That's what we were talking about over here. If these are perpendicular, then the slopes are opposite reciprocals, meaning that if I multiply them, I would get -1 over 1, because 2 times -2 is -4. Or sorry, this is I had to flip this, so change that in your notes. I forgot to flip that. So you got to do 2/3 and then flip it, and then make a negative. So 2 times -3 is -6, and then 3 times 2 is 6. -6 divided by 6 is -1. So when I multiply opposite reciprocals, which are perpendicular slopes, then I get -1. So it says multiply the slopes of each pair of adjacent sides next to each other, okay? So the sides next to each other. Okay, so then let's go ahead and do that then. So these sides are next to each other. So if I multiply them, I get -3 over 3, which is -1. And the same thing for these ones. These sides are next to each other, right? So I can multiply those. So I do get -1 when I multiply the sides next to each other for the slopes, okay? So that means it's got to be this one. And so what we just shown is that these are perpendicular, so that these are actually right angles, right? These are right angles. And therefore, what we have here is a rectangle. And we know it can't be a square because the sides are not the same length, but it does have right angles, so it's a rectangle. All right. So now number 23, look at the figure. Select all ratios that are equal to the sine of angle P. All right, so this is chapter 9 stuff, sine, cosine, tangent. So let's go ahead and do that here. So remember SOHCAHTOA, sine of an angle, let's just say theta, is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. So those are the things here, right? That's how you form the fraction. All right, so here we're talking about sine of angle P. So we're looking at this angle right here. All right, so we know that using this right triangle, if I look at just this right triangle here, change the color here, look at just that right triangle, that this is opposite because it's opposite of that, and this is hypotenuse right here. Okay, and that's just looking at that triangle. So opposite over hypotenuse, which means it's going to be UV over P. Okay, VU over PV, sorry, VU over PV. So this looks good right there. All right, so now we also want to see, okay, let's look at now this triangle, right? And so opposite of that is this one, and then hypotenuse is this one, right? So it's going to be PT, or it's going to be TS over PT. It's like that one. And then finally, I can do it in terms of this right triangle. So this is going to be opposite over hypotenuse. So it's going to be RQ over PR. All right. So there you go. So that's it. All right. So number 24. It says a 30-foot ladder leans against a wall as shown. The base of the ladder makes an angle of 60 degrees with the ground. How far up the wall does the top of the ladder reach? Okay, so we're going to go how far up the wall. So we're doing, this is a right triangle. We are looking for X, right? We'll call that X, how far up the wall. Okay, so now notice that this is a right triangle. Okay, so notice, let me just, I'm just gonna call this X right here. Sorry about that. So let's draw that right triangle. And then what we're gonna do is we're gonna look at our formula sheet. So this is a special right triangle, which is on our formula sheet, okay? So on the formula sheet for 30, 60, 90s, you can look this up, that this side is X, or we're just going to call it A instead, and then this side is X square root of 3, but I'm just going to call it A square root of 3, and then the side between the side between the two angles here is 2A. Okay, this is from your formula sheet. And now we can see from this that these are equal, so 2A is equal to 30. We can divide by 2 on both sides. We get A is equal to 15. All right, and then we can see from, from this, those two sides that match up, that X is equal to A square root of 3. So then now you could just plug this into there and get 15 square root of 3. All right, that's all there is to it. All right, so now let's look at number 25. In triangle ABC, E is the midpoint of AB, and G is the midpoint of segment BC. All right, so this is the midpoint, so that means this is cut in half. This is the midpoint, that means this is cut in half. Select all the true statements. The length of line segment EG is 1/2 the length of line segment AC. All right, so let's look at that. So the theorem says that if I have a triangle that's cut in half like that, then this is going to be parallel to that line, as long as these are cut in half. And not only that, if this side is 5, then this side has to be 10. It has to be double the side that is parallel to. okay? It's a double half relationship, and that's called a triangle mid-segment theorem. Okay, so know the name, triangle mid-segment theorem. All right, so the length of line EG is 1/2 the length of line AC. Yes, that is true based on what I just said. The length of line segment EG is 3/4. No. The length of line or line segment EG is parallel. Yes, that's what we were talking about. They're parallel. All right. And then line segment EG is perpendicular to line segment AB. Let's see here. So this is not necessarily true. This doesn't necessarily have to be a right angle. It could be any angle. Okay, so I could have a triangle that looks like that. Hold on, let me see if I can draw better than that. I could have a triangle that looks like that, for instance. In which case, see, it's not a right angle, but it's cutting this in half and cutting that in half, right? And these are parallel. So it doesn't have to be a right angle, so it's not guaranteed. Okay, so we can't choose that one. The length of line segment AE is equal to the length of line segment BG. AE is equal to EB. Okay, so because they're cut in half, but AE is not guaranteed to be the same as BG, so no. BE is equal to CG. BE is equal to CG. No, that's not guaranteed. Okay. All right, so that is going to be it. All right, so that's going to be it for the video, guys. Hope you found this useful and informative, and as usual, I'll see you in the next one.